Hello friends, I'm Parvez and today is our 7th lesson in Python OpenCV, Python 3 and OpenCV. Today I will talk about image blurring and image smoothing in Python OpenCV. Okay, first of all, image blurring is achieved by convolving the image with a low-pass filter kernel. It's useful for removing noises, edges, and it actually removes high frequency content like noise, edges, and etc. from the image, resulting in edges being blurred when this filter is applied. There are blurring techniques which do not blur edges, and OpenCV provides mainly some blurring techniques that we will discuss about it. The first blurring technique that we will discuss, that is averaging. And this blurring and averaging blurring, this is done by convolving the image with a normalized box filter. It simply takes the average of all the pixels under kernel area and replaces the central element with this average. This is done by the function cv2.blur or cv2.boxFilter. Okay, now in here I have an image. I want to perform averaging blur in this image. Okay, first of all, I should import cv2. Okay, now we should read our image, cv2.m read, and our image name is there .png. okay, gpg, sorry, gpg. Okay, now we want to show our image, cv2.mshow. I give it original and our image. Okay, now cv2.wait key 0 and cv2.destroy all windows. Okay, now I want to run this. We have this image. This is the original image. Okay, now I want to perform the averaging blur. Okay, first of all, in here you should write blur cv2.blur, and we want to perform blurring on our image and give 5 by 5. Okay, now I want to show this, cv2.mshow. in here we write blurring and our image, our blur. Okay, now I want to run this. You can see that we have blurred this image. You can see the difference between those two images. This is smooth and blurred. This is the original and this is the blurring image. Okay, and now this was the first blurring. The second type of blurring is Gaussian filtering. In this approach, instead of box filter consisting of equal filter coefficient, a Gaussian kernel is used. It is done with the function cv2.Gaussian blur, and we should specify the width and height of the kernel, which should be positive and odd. We also should specify this standard deviation in the x and y directions, like sigma x and sigma y respectively. If only sigma x is specified, then sigma y is taken as equal to sigma x. If both are given as zeros, they are calculated from the kernel size. Gaussian filtering is highly effective in removing Gaussian noises from the image. Okay, now we will perform our this Gaussian. I remove this. Okay, now I want to make a function. I give it Gaussian Blur. CV2 dot. We have a function in OpenCV. Gaussian Blur. We give our image and 5 by 5 the width and height, and the sigma is 0. Okay, now we want to show this. Okay, now I run. You can see this is different from the first one. This is a little smoothing and blurring. The first one was more. Okay, now another kind of filtering is median filtering. This is I think this is the best filtering. And here we have a function cv2.medianBlur computes the median of all the pixels under the kernel window, and the central pixel is replaced with this median value. This is highly effective in removing like salt and pepper noises. One interesting thing to note is that in the Gaussian and box filter, the filtered value for the central element can be a value which may not exist in the original image. However, this is not the case in median filtering, since the central element is always replaced by some pixel value in the image. This reduces the noise effectively. The kernel size must be positive and odd integer. Okay, now in here I have an image. I remove this. I have I think what was the name of image? Median.gbg. This is I have added a little noises in this. Okay, now I want to perform the median filter in this. Okay, first of all, import cv2. Now we want to read our image. cv2.mread median.jpg. Now cv2.mshow original and image. Okay, now cv2.wait key, cv2.destroy all windows. Okay, now I want to run this. Okay, this is our original image. Now I want to perform in here in this section. Simply write median cv2 dot median blur. Okay, write image and give it 5. Make sure that it should be an odd number. Okay, now I want to show this cv2.mshow median blur and our median. Okay, now I want to run. You can see that this is a little better. It removes some noises. Okay, now I want to change this to 9. Now you can see that it is more smoother than this and more blurred than this. Okay, if I change this to 11, you can see that this is more better than and more blurred. Like this you can play with these numbers. And thank you guys. If you have any question, please let me know, and for the further videos please subscribe my channel.